Welcome back to Lecture 4, Section 21. This is 21 in your textbook. Definition. A function f is a correspondence or rule which assigns to each element x of a set A exactly one element f of x in a set B. So what does that mean exactly? What this is saying is that you have a set, we'll call this A, there's your set A, and you have a function that maps f into a set B. So again, inside of A, you're going to be taking a little point, say x, and then you look at what does f of x do, and f of x is going to take that little point and put it inside of, say, f of x, inside of B. So really it's a mapping. So all the definitions deal with this concept of a mapping, and I have them color-coded. The domain is the set of all possible values of the independent variable. So that's where do you start. The range of f, this is the set of all possible values of the dependent variable. And again, that sounds very complicated, but really that's saying where do you end. So again, f takes x and maps it to f of x. And that's all a function really is. Now there are several different ways to define a function. First of all, we have algebraically. Algebraically, this is just equations that you've seen before. So you've seen equations. For example, you can have something like, I don't know, f of x is equal to x squared, right? Or something to that effect. So what this says is that every time you see x, well, what do? You square it. Again, that's the algebraic notation. 2, you have graphically. Graphically says, well, what does this thing look like visually? Graphically, you're going to have your, what we call our independent axis, or your abscissa, and then you have your ordinate, which is your dependent axes, and then you graph your function accordingly. So again, you're going to have your x and your y. So, for example, that's what your typical x-axis looks like. X and y-axis looks like with the function x squared. You can also have 3, say a table, numerical values. You can have a table numerically. And that's so. For example, if I had something that looked like x and f of x, which is, say, x squared in my little example that I gave. If I put in 1, 1 squared is 1, and if I put in 2, then 2 squared is 4. So again, I can have a table. Let's see. Lastly, I can do is verbally. And again, this is what you can say out loud. And since I'm doing audio recording, I can just say something. So I can say, for example, the students in a given lecture, that's your independent variable, match to their birthday. That's their dependent variable.